Hello again. To continue on with the lesson on phase shift in sinusoidal curve fitting, because of time constraints, we have to continue to move on, and this ties in a lot with what we've been doing anyway. And that is, what about the inverse sine, cosine, and tangent functions? Now, we talked a little bit about inverses earlier, I believe in chapter 2, where we switch the x and y, and the domain of the function becomes the range of the inverse, and the domain of the inverse function becomes the range of the original function. Well, inverse functions are very important, and here is why. Because they allow us to undo, basically, so to speak, the sine, cosine, and tangent. They allow us to find angles. Okay, before, when I would tell you, hey, what's the sine of pi over 6? Well, you would say 1/2. Well, now we're going to have the capability to take the inverse sine of 1/2 and get pi over 6. So if you look on your calculator, you will see that you have a button sine, and above it, it says sine to the negative 1. Cosine, cosine to the negative 1. Tangent, tangent to the negative 1. Those are the inverse functions, these right here. They undo sine, cosine, and tangent, respectively. Now, when we find inverses, however, there are going to be some rules that we have to follow. Because remember, if you recall, all functions don't have inverses. The reason being is that if you have a graph that looks like this, let's say, remember that this x could be 2, so y would be 4, but this x could be 2, and y would also be 4. That did not allow us to have an inverse. So we had to look only at a certain domain in order to find its inverse. Now, we didn't go into that very much like we will when we get into chapter 10, I believe it is. But for the sake of what we're doing here, just accept it, okay? That would be my best advice here. And this is where it comes from. So here is our sine curve, all right? Now, we know that our b, our y, goes from negative 1 to 1. That is our range, okay? This is our range. Well, we cannot look at more than a certain part of the unit circle or of this graph, because you can see we have multiple places where our x's and y's are the same, and we can't do that. It just doesn't work. So what we need to look, because we have multiple x's for one y, which means if we take the reverse of that, the inverse of that, we'd have multiple y's, or we'd have one y mapping to multiple x's, so that wouldn't be a function. So what we have to do is we have to limit it. So what we do for sine and inverse sine is this. We actually are going to look at it here. So we are going to look at only from negative pi over 2 to positive pi over 2 on the graph. That is all we're going to look at for an inverse, okay? Excuse me. So here's the portion of the sine curve from negative pi over 2 to pi over 2. The inverse function would look like this, the red one. You see how, remember on an inverse, if you graph the y equals x line, they have to be mirrored or reflected on that line? Well, we couldn't do it if we used the entire sine function. So now we're going to only look at it from negative pi over 2 to positive pi over 2. Which means, guys, That's the fourth quadrant and the first quadrant on the unit circle. So inverse sine, and I skipped a lot here, all it means is this, and this is how you write it, okay? Y equals inverse sine of x is how you read it. So all this means then is that we can only find the inverse sine of a number that corresponds to the angles between negative pi over 2 and positive pi over 2. Or in other words, quadrant 4 and quadrant 1 on a unit circle. So if this is my unit circle, I'm only looking at these angles in quadrant 1 and quadrant 4. And that means it's negative pi over 2 to positive pi over 2. So remember, if you go clockwise, it's a negative angle. And I'll give you some examples of that here in a second. Okay, so here's an example of finding inverse sine. So y equals inverse sine of radical 3 over 2. You want to read that as when is sine radical 3 over 2. So you ask yourself that. Well, so think of a unit circle, Think of a unit circle. Let's see. Pi over 3, 60 degrees, right? Is radical 3 over 2. And also here, right? This is radical 3 over 2. So I believe that's 120 degrees or 2 pi over 3. So it has two answers, correct? Incorrect. Right, because we're only looking at the first quadrant and the fourth quadrant. That's it. So it's the only answer then is pi over 3. Okay? Even though it happens in both places, inverse sine is only good in these two quadrants. Okay? How about the inverse sine of negative radical 2 over 2? Okay? Well, let's think about it. When is sine negative? Well, sine's negative there, and it's negative there. Well, obviously, that's got to be a 45-degree angle, right? And that's got to be a 45-degree angle. So remember, it's only good between negative pi over 2 and positive pi over 2. So that means this angle going down is negative pi over 4, or 45 degrees, instead of positive pi over 4. Positive pi over 4 is up here. So the answer then is negative pi over 4. But whoa, Mr. Thamer, what about this one? Well, that is not in our domain, because our domain only works in the first and fourth quadrants. That's it. So the inverse sine of negative radical 2 over 2 is simply negative pi over 4. All right? I'm going to go ahead and do inverse cosine, and inverse tangent, and then we'll do some problems. And I think that'll help you understand it a little bit better. Well, here's cosine. And again, cosine has problems because, again, this horizontal line goes here, here, here. So we're going to have to limit its domain as well. So for cosine, mathematicians chose to limit it between 0 and pi. And then when you take the inverse cosine, you end up with that graph. So there's the reciprocal, or there's the let's see, the blue one is the inverse cosine. The red one is the cosine, the one we just saw that was in blue, but now it's in red. That's kind of dumb. So again, though, if you grab the y equal x axis, you can see that it's reflected. So this is the inverse of cosine. Now, remember, we're only looking at inverse cosine here. So from 0 to pi, that's it. We're only looking at quadrant 1 and quadrant 2 for our answers for inverse cosine. So find the exact value of y equal inverse cosine of rad 3 over 2. So you ask yourself, when is cosine radical 3 over 2? Well, then you could do this if you wanted to. Okay, well, radical 3 over 2 is there. This would be 1/2, so that's 30. So it's pi over 6. But negative 30 also works, right? So negative pi over 6. Well, wait a minute. Remember, inverse cosine is only good between 0 and pi. So we just have one answer, pi over 6. Okay? Find the exact value of y equal inverse cosine of negative radical 2 over 2. Okay, so ask yourself, when is cosine negative rad 2 over 2? Well, that's over here. So 45 here and 45 here, right? That's negative radical 2 over 2. So I believe this is 3 pi over 4 and this is 5 pi over 4. So which one's correct? 3 pi over 4, because it's only in quadrant 1 and quadrant 2 that inverse cosine is defined for. So it's 3 pi over 4. Now, inverse tangent, you can guess you're going to get the same ugly result. And there's tangent, and this is what we're going to limit it to. Negative pi over 2 to pi over 2, which means quadrant 1 and quadrant 4. Again. And there's the graph, the inverse, and here's our y equal x. And you can see that it's reflected. And this is the inverse tangent. So, find the exact value of inverse tangent of negative radical 3. So here's what we need to remember. We're only looking at, right, the quadrant 1 and quadrant 4. That's it. From negative pi over 2 to positive pi over 2. So when is tangent negative radical 3? Okay, so let's draw this out. When is tangent negative radical 3? Well, that's when it's got to be 1 or 4, right? So these are tangent's positive here, so it's got to be negative down here. So that would be negative radical 3 over 2 and 1/2, because it's y over x. That would be negative rad 3 over 2. So what is this angle? Well, that'd have to be a 60, wouldn't it? So negative 60, which is negative pi over 3. And that's what we got. Now, I said we're going to do some more problems. So let's get your work out here today, and let's talk about a few of your problems. So if you look at your worksheet, number 1 is the inverse sine of 0. Well, when is sine 0? That's what you ask yourself. Well, the sine of 0, when is y 0? That's at 0 and pi. But remember, it only works in quadrant 1 and 4, so it's 0. Pi over here doesn't work because it's not between negative pi over 2 and positive pi over 2. Number 2, inverse cosine of negative 1. Okay, well, let's think about cosine. Inverse cosine, it only works in quadrant 1 and quadrant 2, from 0 to pi. Here's pi over 2 up there. So when is cosine negative 1? Right here. So that would be pi. Okay, it's not so bad. Let's find an inverse tangent. Oh, here's one, number 4. Inverse tangent of negative 1. Now, where is tangent defined for? Or inverse tangent, I'm sorry. Right, from negative pi over 2 to positive pi over 2, right here. So when is tangent 1? Oh, that's easy, 45 degrees, isn't it? Well, we want these in radians, so that would be pi over 4. If it was down here, it'd be negative pi over 4. If this said negative 1. Oh, it does say negative 1. My bad. It says negative 1. So that's down here. So that's negative pi over 4. Okay? Now on 10 through 15, use your calculator. Use your calculator and make sure you're in degree mode. Okay? Make sure you're in degree mode. Let's look at like number 16. It says the sine of the inverse sine of 0.54. So let's think about this. First of all, is 0.54 between, so it's not the angle, guys, it's the ratio. So it's like radical 2 over 6 or something. We don't know what 0.54 is. But we're taking the inverse sine of that measurement to get an angle. And then we're going to take the sine of that angle. Well, these two things undo each other. So it's simply 0.54 if we're in the correct quadrant. Well, 0.54 is in quadrant 1, so we're good. Okay? 17. The tangent of the inverse tangent of 7.4. Okay, well, let's see. 7.4, oh yeah, that's in the first quadrant. That can be in the first quadrant, y over x. So, let's see. So tangent of the inverse tangent, they just cancel. So it's 7.4, so we're good. Let's go to one that we have to think about. Here's one. 22. The cosine of the inverse sine of radical 3 over 2. All right, now do one thing at a time. When is sine radical 3 over 2? If you said 60 or pi over 3, you are correct. So now, what's the cosine of 60? Or the cosine of pi over 3? 1/2. So the cosine of the inverse sine of rad 3 over 2 is 1/2. Cool. By the way, do not do 19. 19 is a no-go, bad problem. It's a typo, actually. I'm going to pick one more of these. Let's go with 29. 29 is the inverse cosine of the cosine of 5 pi over 4. So immediately, most of you will just cross these out because they undo each other, and you will write 5 pi over 4. But that is not correct. Because where is 5 pi over 4? It's down here. Inverse cosine only exists from 0 to pi. It only exists in quadrant 1 and quadrant 2. So now, what is the cosine of 5 pi over 4? And we better talk about that first. Well, that's right here. That's a 45, right? When you see that, you know it's a 45. It's negative radical 2 over 2. Well, then we got to take the inverse cosine of that. So we're taking the inverse cosine of negative radical 2 over 2. But that would be in the second quadrant. It'd have to be in the second quadrant. And that would be 45 here. So your angle would be right there, 135 degrees, right? Which is 3 pi over 4. So as weird as it looks, the inverse cosine of the cosine of 5 pi over 4 is actually 3 pi over 4. Okay? Now, you might want to take some time to really look that over too and replay this again and try to understand it if you don't understand why you cannot be in the third quadrant with this answer. Okay? I am going to do one more here. 32. The tangent of the inverse sine of 1/3. Now, none of us know what the inverse sine of 1/3 is, but we can draw it. We know that sine is y over r. We know it's positive, and the inverse sine is only positive in the first quadrant. So we need to find x if we're going to find the tangent. So here's my angle. So this is actually our triangle. So 1 squared plus x squared equals 3 squared. So that's going to be, what, 8? So x equals radical 8 or 2 radical 2. So x is 2 radical 2, so now we want to know the tangent. Well, the tangent is y over x. Now, I would accept this answer, but to be technical, we should simplify it. And it is radical 2 over 4, because these two end up being 2, and it's 2 times 2, which is 4. So digest that. You're going to do the same thing on 33, 34, 35, 36. You're going to draw a triangle and just evaluate the trigonometric functions. Okay?